All right, we are talking about scope and access today. So scope is going to define where in your program variables exist and are able to be accessed. So where you can use a variable in your program. And this is most often going to be defined by where that variable has been declared. So where you make that variable is going to tell you where it's able to be used. We talked about scope a little bit when we were discussing nesting for loops. So we had our string outside, we had our int I and our int j. That word is available for use throughout that whole program. I is only accessible within that outside for loop, and j is only accessible within this inside for loop. So if I try to use j outside of its for loop, it's not going to exist. It's out of scope. So we have our descending levels of scope there. So if I try to print j here, we get that error. You may have forgotten to declare j, or it's out of scope because it no longer exists. It has exited its existence. So when something is out of scope, that means it doesn't exist anymore. So if it's in scope, it exists. If it is out of scope, it has stopped existing. Scope is also going to apply to methods and classes. So any variable that you declare within a method is going to be called a local variable. And those are only in scope. They only exist inside of the method in which you declared them. So local variables to methods cannot be declared as being public or private. So since they only exist inside of a method, you can't have other classes gain access to them. So as an example, here we have a class called example. It has two methods written inside of it. It has add1 and sum. Both of them are going to accept at least one parameter, and they both have some number of variables defined inside of them. So both result and sum are local to their own methods. So result is only accessible from within this add1 method. Sum is only available within this sum method. Like I just said, neither of those can be private or public because after this method is over, they stop existing. So other classes will never even need to know that they exist because they are local to this method and only to this method. And even if I change this variable that was called sum to be named result, there's not going to be any problems. Even if both of those have the exact same name, since they are local to separate methods, they're completely separate from one another. They're not going to overlap. No. Despite the fact that they have the same name, since they are in different scopes, they're not going to interfere with each other. Formal parameters are also going to be local to their methods. So after your add1 method is over, this int x is no longer going to exist. Any questions on any of this thus far? That all makes sense? All right. So in general, variables are going to exist. They will be in scope from the point where they are declared until the end of the block in which they were declared. And blocks are determined by curly braces. So from the start to the end of a curly brace, that is a block of code. So in a variable is going to exist from wherever it's declared inside of a block until the end of its block. So we have another example class. We have our instance variable. We have this int x. We have a local variable, and we have our int I. So instance variable is going to exist throughout this class. My parameter x is going to exist everywhere within this method. Local variable, very similar in scope, except that it's defined one line later. And our int I is only going to exist within its for loop. So we have, once again, decreasing levels of scope where different variables are accessible and usable. So similarly to how scope works within methods, it also works within classes. So if you have two variables in separate classes from one another that have the same name, they're not going to interact with each other because they have separate scopes. If you ever have two variables with the same name inside of the same scope, this is called shadowing. In this scenario, the variable with the more specific scope will take precedence, and it'll overshadow the one with the more general scope. That one is just not going to exist. So it's not going to be used when there is a shadow happening. So if I have a calculator class, I have an instance variable called number, and I have a method called print number in which I am defining a variable number. This number is going to overwrite, going to shadow over my instance variable. So when I print number, I'm going to print 10 instead of 0, because both of those variables have the exact same name. So number, since it has the more specific scope, it has the smaller box, it's going to be used. And in this scenario, if I move my number to be a parameter, I still have my instance variable. That parameter still has a more specific scope than my instance variable, which is why when we do a constructor, if we have a parameter with the same name as our instance variable, it doesn't actually initialize our instance variables because the parameter has the most specific scope. So it's the variable that's going to be accessed. So if we want this to actually print out our instance variable, we need to have no references to the declaration of a variable called number within this method. So there's the only one in scope is my instance variable. Yeah. All right. And we can avoid scope and access errors by using an idea called method decomposition, which is really just going to involve planning out what our program is going to look like before we actually write any code. So figuring out what things are going to do, how things are going to work before we write any code. So we want to break down large problems into smaller subproblems and then create methods that will solve each of those individual subproblems so that when we have our entire code, we can just call those methods to solve our problem at large. As an example, let's say we want to write a program that will ask the user a random trivia question and tell them whether or not they got the answer right. There's two steps we need to take. We need to build a trivia class, and we need to make a program to interact with that trivia class so that we can actually ask questions, get responses, all that stuff. So let's focus on creating a program to interact with that class so we know what we'll need to build into that trivia class. So if I want to actually interact with this trivia class, we're going to need to know what we need to do. So we're going to need to make an object of the trivia type. We're going to ask the user a random trivia question. We're going to let the user respond. We're going to just ask for user input. And we're going to check if the response matches the answer and tell them you got it right or you got it wrong. So just within here, we can see some things that we would need our trivia class to be able to do. We'd need to be able to create objects. So we need a constructor. We need to be able to get a random trivia question. And we will be able, or need to be able to check if our user's response matches their answer. So each of those could be a method or a constructor. So with that outlined in our head, we have a general idea of what our trivia class is going to need. We need to build our constructor. We have those two additional methods for getting our question and checking our response. We're going to need to determine what instance variables are going to need to exist within our trivia class, a list of questions, a list of answers, and we might need to implement access or mutator methods if we need to. We might not need to at this point, because get question is probably going to handle our retrieval of questions and answers. And if we We don't need the user to be able to change the questions or answers. So we might not even need accessors or mutators here. And even without a full implementation of what the trivia class is going to look like, we are able to write out what our program interacting with it might look like. We can fill in the trivia class at a later point in time. So to create a trivia object, we're just going to call the constructor. If I'm getting a random trivia question, I can call my game.getQuestion method and print that out. I can ask the user to respond using my scanner variable. I usually call mine in .next line, getting their response. We can check if our response matches the answer using another method in our trivia class. We're going to check response with that response variable from our game object. And if they were correct, we'll print correct. Else, we'll say, sorry, you were incorrect. So this is going to let us determine what kinds of things we need to build into our trivia class. So we can see those methods that we need to build. So if I want to run this test, we have this code written out. This is one of the example programs for today's method module. So we have the whole trivia class is actually built out at this point, and we have our trivia game. So if I run my code, Ankara is the capital of which country? Does anyone know?
What was the question?
Ankara is the capital of which country? Ankara, A-N-K-A-R-A.
Croatia.
Serbia. Croatia was not correct. And if I run it again, it will be a different question. So I can't check if it's Serbia. But I can check the code. And the answer is Turkey. Well, none of us knew the answer. That's why it's trivia.
It was Istanbul or something. Or maybe that's just a famous one.
That's just a famous city, yeah. Yeah, that is how method decomposition works. We break down our problem into smaller chunks, solve those individual chunks with methods. All right. Any questions on scope, method decomposition, any of that stuff? All cool? Great. All right.